Live from the Space Coast of Florida, Lucy is on the ground but headed towards some asteroids. And this is NASA's launch coverage of the Lucy mission.
Lucy in the sky with asteroids. In L-34 minutes, this Atlas V rocket will send Lucy on the first ever space mission to study the Trojan asteroids, which share Jupiter's orbit around the sun.
Named after the Lucy fossil, the spacecraft will visit 8 asteroids over 12 years as we seek to uncover the mysteries of our solar system's formation. Welcome and thank you for joining us here at NASA's Kennedy Space Center on the east coast of Florida. I'm Daryl Nail, and we got a great launch for you.
That's right, and I'm Marie Lewis, and we are both vaccinated against COVID-19, which is why we're not wearing masks since we're outside. Launch is set for 5:34 this morning Eastern Time from Space Launch Complex 41 at Cape Canaveral Space Force Station, and we are at L-32 minutes and counting.
No spacecraft has ever been to the Trojan asteroids. They are considered fossils of planet formation and may hold clues about our ancient past. With boosts from Earth's gravity, Lucy will fly very close to 8 asteroids over her 12-year journey. Just as the Lucy fossil has been extensively studied, the Lucy spacecraft promises to teach us about our solar system's evolution, including Earth.
Now, no other space mission in history has visited as many different destinations in independent orbits around our sun. And we'll talk with the experts about Lucy's unprecedented journey ahead.
That's right, and we'll also hear from the man who discovered the ancient Lucy fossil in Ethiopia in 1974.
We'll learn about a special time capsule associated with this mission.
Plus, we'll hear directly from the scientists who've spent years working towards this day.
And to help us tell their story, we have commentators at the United Launch Alliance Atlas Spaceflight Operations Center, or ASOC as we call it. We also have folks on the roof of that building and at a nearby viewing location. First, let's introduce you to the team of commentators who will be calling the launch today, NASA's Joshua Santora and Mick Waltman. Guys, how's it going over there?
Hey, it's going almost unnervingly well. Everybody knock on wood. Start knocking on wood. But I'm joined here with Mick Waltman, the Chief of Fleet Systems Integrations. Mick, always a pleasure to have you with me.
Joshua, thanks. It's an exciting time this morning. As you said, it's been a pretty quiet count so far. The teams came on, several hours ago and started preps to get the vehicle ready, and things are looking great. I mean, everything's go so far this morning. We are in this T-4 hold, and the team is finishing up topping and doing their work. So looking forward to that T0.
Yeah, it's coming up here. We're on track still for the first opportunity of a 75-minute window. But again, we started fueling about 2 hours ago, and then just about 30 minutes ago, we got into a topping phase with all of our fuels and oxidizers, which basically means that we're at a point where the vehicle's fueled, it's ready. They're simply going through final checkouts and processes, stabilizing and making sure that we're good to go here. Obviously, under the beautiful Lucy spacecraft today, we've got the Centaur upper stage and then the Atlas booster. Mick, a unique Atlas booster, not originally intended for this flight.
Yeah, that's true. When we started this mission, the first stage of this Atlas 401 configuration was originally allocated for the OFT-2, or Orbital Flight Test 2 mission that was earlier this year. However, due to some manifest things that went on and due to the nature of Lucy and the planetary window, we had to work with United Launch Alliance to reallocate that booster, reconfigure a little bit, and get it ready for this morning's launch. So the booster, of course, reallocated from OFT, but the Centaur is brand new for this mission. And as you were saying earlier, finishing up topping, we're getting about 740,000 pounds of fuel on board once we finish fueling here, get ready for launch this morning.
Yeah, so things progressing well. A lot of what's left is to get Lucy ready to be living on her own and flying free. And so as we look ahead to the countdown, we have a few things coming up, including a weather check. We also have the spacecraft moving to internal power, and lots more to come. We're excited, so even beyond liftoff today, stay with us. I think that's going to do it for us for the moment. Again, lots more to come ahead. Marie, we're going to send it back over to you.
All right, thank you, Joshua and Mick. We are now at L-28 minutes, 25 seconds and counting. The Trojan asteroids Lucy will visit are named after characters in Homer's famous poem, The Iliad. They are called Patroclus, Menetius, Euripides, Orus, Lucus, and Polymele. And the main belt asteroid Lucy will visit is called Donald Johanson, after the man who discovered the Lucy fossil. Now, the 8th asteroid, Keta, is a small satellite of Euripides. Keta was named after the first woman to light the Olympic cauldron, Norma Enriqueta Basilio Sotelo. We'll show you how Keta was discovered a little later after launch.
Right now we are L-27 minutes and counting. Lucy is inside the payload fairing, sitting on top of the United Launch Alliance Atlas V rocket on pad 41. We want to show you what she'll look like once she's flying free in space. Lucy is more than 46 feet long, about the size of a large RV. Most of that length is from her huge solar panels, each almost 24 feet long. Lucy has a 6.5-foot antenna with which she communicates with Earth. And there are 3 main instruments for remote sensing. Fully fueled, she weighs 3,417 pounds, a little heavier than a mid-sized car, and most of that weight is fuel.
Yeah, those solar arrays are really impressive. And studying the Trojan asteroids from hundreds of millions of miles away requires a highly advanced set of instruments. Let's learn more about what's on board Lucy.
The Lucy spacecraft will be taking a journey where no other spacecraft has gone before, the Trojan asteroids. The Trojans are 2 groups of asteroids that lead and trail Jupiter in its orbit around the Sun, and they've been trapped in these stable locations for over 4 billion years. Lucy will have a suite of scientific instruments for collecting data as it flies by the asteroids. LaLaurie is a long-range reconnaissance imager. It's often referred to as Lucy's eagle eyes, since it has the highest spatial resolution of all of Lucy's cameras. This black and white camera is actually a type of telescope, the same kind as the Hubble Space Telescope. LaLaurie was built to produce clear images of the Trojans' craters, which will be a challenge since the Trojan asteroids are extremely dark. LaLaurie will be able to see 75-yard wide craters from over 600 miles away. That's like standing at one end of a football field and being able to see a fly at the other end. The instrument's simple design does not use optical filters and includes no moving parts, reducing the risk of part failure during the mission. LaLaurie will also search the Trojans for evidence of any rings and new satellites. The instrument's ability to see faint targets from far away also makes it perfect for optical navigation. LaLaurie will help Lucy navigate to a point in space, and then a terminal tracking camera aboard the spacecraft, known as T2CAM, will help the instruments accurately point towards the targets. LITES is Lucy's thermal emission spectrometer, which detects far infrared radiation emitted by the asteroids due to how they are heated up by sunlight. LITES detects this radiation using a small telescope to focus the incoming energy onto a detector, similar to the way a remote thermometer works. So, LITES is not taking images, but rather temperature measurements at various points on the asteroid. This data will be combined so that scientists can get an understanding of its surface properties. LITES will examine the properties of the regolith on the surface by measuring thermal inertia, which is the measure of how slowly the asteroid heats up from sunlight and then releases that heat. By taking the temperature readings at different parts of the asteroid, the Lucy science team can measure the thermal inertia and figure out how much dust, sand, or rock is present on the asteroid's surface. That data will tell us a lot about how the asteroid was formed. providing insight into the history of our solar system. Lucy's LaRalph instrument will search the Trojans for organics, ices, and hydrated minerals, and will help determine the surface compositions of the asteroids. LaRalph is actually 2 instruments in one, and together they will measure and analyze the spectra of light absorbed and reflected by the asteroid. The first is a color visible imager, the Multispectral Visible Imaging Camera, or MVIC. It takes visible light color images of the Trojan asteroids. The second is an infrared imaging spectrometer, known as LISA, the Linear Etalon Imaging Spectral Array, which collects infrared spectra of the asteroids. Like LaLaurie, LaRalph does not have a focusing mechanism. Instead, it is designed to stay in focus despite the extreme temperature differences in space by being made almost entirely from a single block of aluminum. As you can see, the Lucy spacecraft has a large suite of tools to study the Trojan asteroids, which will help us better understand the formation of our solar system.
You may have noticed in that video that each of Lucy's instruments has an L added to the beginning of its name. That's meant to designate their attachment to Lucy. And now we're going to hear from the Deputy Principal Investigator for the Lucy mission. She is standing by with NASA's Megan Cruz at the nearby Operations Support Building 2. That's our launch viewing location. Megan, how's it going over there?
Hey, Marie, things are looking really great, and it just got better now that I'm joined with Kathy Olkin. Kathy, thank you so much for being here.
Thank you for having me.
Yeah, absolutely. You know, Lucy is a very ambitious mission. Where did the idea for Lucy come about?
The idea for Lucy was really to explore the Trojan asteroids. The scientific community has been wanting to see these objects up close for a long time, and so we finally have a mission that's almost on its way.
Yeah, this is really exciting, and I mean, the goal is to study how the outer planets formed, but why is that important for us to understand?
Yeah, it's really important to understand solar system formation, to understand where we came from and how our solar system works. It used to be that we had a vision that the solar system was a very calm environment and that everything was very stable. But really, our recent ideas are that it's not like that at all. It's it had been very chaotic in the early solar system history, and that caused small bodies in the solar system, many to be ejected out of the solar system, and a small fraction to be captured in the Trojan asteroids.
Gotcha. And it's going to take a very complex trajectory, right, to get to these Trojan asteroids. I imagine that must have been really difficult to plot out 4 billion miles over 12 years.
It really was. It took the whole team to be able to make this amazing trajectory that really enables the mission. On the science side, we started with a list of objects that we wanted to compare against each other. And then we handed that off to the mission designers, and they ran with it, and they found an amazing trajectory. And then the people who optimize the trajectory did their work. And so it's really effort from the whole team that got us this awesome trajectory.
Perfect. And a quick last question, why 8 asteroids? That's a record-breaking number.
It is a record-breaking number, and we really needed to go by 8 asteroids to really explore the diversity of these objects. There's more red and less red, there's smaller and larger objects, there's objects that we're going to be visiting that are remnants from a giant collision, and also a primitive pair, a binary pair that orbits each other. So in order to make all those comparisons, we needed to go past 8 asteroids.
Kathy, thank you so much. It sounds so exciting, and honestly, we're so lucky because the weather looks so great right now, right, Daryl?
Right, Megan, the weather is cooperating wonderfully. You can't see it because it's dark out,
right.
But we've got great weather. Had a little bit of rain coming in.
Just a little sprinkle.
Just a little sprinkle, but it looks clear overall. Let's take a look out at the live shot of our pad and the rocket, and you can see there it is, looking beautiful in the light. Just a note for you, in the upper left-hand corner, there's the L- time, L-19 minutes and counting. Across the bottom, the progress bar. You see we are in a T-4 hold. More on that in a bit. But we're talking weather now, as you can see, clear through the dark. This is so that ground teams and launch teams can see what's going on with that illuminated pad and monitor what's happening around the rocket. Let's talk more about the weather. And yeah, we had a little bit of rain earlier, Will Ulrich, our launch weather officer, but overall this is looking fantastic from a forecast perspective.
That's right, Daryl. Really, all things considered, we couldn't be asking for better weather early this morning. Those sprinkles that you mentioned have since cleared the area, and now all we're left with is partly cloudy skies and light winds, thanks in part to an area of high pressure that remains dominating over the southeastern United States. A live look at satellite imagery behind me shows those mostly clear skies across much of the state, and that's going to make for a great viewing opportunity, regardless of whether you're watching in Jacksonville, Tampa, Orlando, or locally right here in the Space Coast. My colleague Jessica Williams just gave her final weather brief at L-30 minutes to United Launch Alliance, Eastern Range, and NASA officials, and gave a greater than 90% go for weather, so we are not tracking any issues at this time. As a reminder, my colleagues and I are here to ensure that the weather is safe for launch, and we do that through the evaluation of 10 lightning launch commit criteria, which are designed to protect against both rocket-triggered and natural lightning. In addition, we also monitor user weather constraints like surface wind speed and precipitation. And while things are looking really good for launch this morning, should we need to utilize tomorrow's backup window, we do anticipate conditions deteriorating as we see a cold front move through the region. But let's not worry about that right now, because conditions are looking great. Mother Nature is giving her thumbs up, and I'm happy to report that the 45th Weather Squadron is go for weather. Daryl?
Great update about the weather outside. Thank you, Will. We are currently L-17 minutes and counting until liftoff. Asteroids are prehistoric treasures that hold the lost stories about our origin of the solar system. Here's what else you need to know about Trojan asteroids. This mission is such an incredible opportunity and one of the many missions aimed at asteroid research right now. Let's head back out to NASA's Megan Cruz, who is with the head of NASA Science Missions. Megan.
I am Daryl. Joining us right now is Dr. Thomas Zurbuchen. He's the Associate Administrator for NASA's Science Mission Directorate. Good to have you here this morning.
I'm so glad to be here. What an exciting morning.
It is, and I'm so glad you're here because I got to ask you a question. You know, first off, tell me a little bit about the Science Mission Directorate. What's the goal there?
Well, so we're the organization at NASA that does all science, you know, and it, of course, is planetary science, just like we're launching today. It's also astrophysics. I just got a picture of the James Webb Space Telescope that in the crate there in Kourou getting ready for launch, and then it's the earth science, heliophysics, also biological and physical sciences. That's all the science we do at the agency. Just an amazing amount.
Yeah, and when you became Associate Administrator of the Science Mission Directorate, Lucy was the first mission you selected. Why is that?
Well, so the timing was there. We had 5 mission candidates, and I have to tell you, it was the first. It's one of these amazing decisions, and of course, many people helped with that. But I looked at this, and this orbit and science was so compelling. I said, we gotta fly this.
Yeah, the trajectory is amazing. I mean, the fact that we've been able to figure out how to get to the Trojan asteroids in relatively a short amount of time. What do you think about that?
Well, I mean, it's so innovative, right? I mean, we actually, the science community had said, we want to do this, but we want to spend $500 million or $1 billion more than this team proposed. It's like, this is good money. Let's go do this. It's really innovative. Mm-hmm. Absolutely.
And how does Lucy tie into NASA's overall asteroid research that's going on right now?
Well, we're really starting a decade of asteroid science, right? We're launching in 23. OSIRIS-REx is bringing back the samples of Bennu down kind of in Utah. We'll come down there. Next year, we're going to be here again and launch Psyche. And just later this year, we're going to launch DART, which is the first collision experiment trying to really deflect a potentially threatening asteroid. So for us, it's many parts. And of course, at the heart of it, Lucy, is just absolutely a mission of discovery.
Yeah, we're really doing a lot of amazing things, and I think that you have a lot to do with that. So thank you so much, Dr. Zurbuchen. I really appreciate you being here today.
Appreciate it, Megan. Thanks so much.
Awesome. Daryl, back to you.
All right, thank you, Megan. And we're just seconds away from the NASA Launch Manager poll, so let's get out to Joshua and Mick to pick it up. Guys?
Hey, thanks, Daryl. Yes, things, again, proceeding really well. Appreciate the report from Will Ulrich, because the weather is always the other side of the coin, right? We've got the launch team in the technical. We got the weather in good shape. As you see there, the rocket venting and having the condensation appear around the rocket as we would typically expect. So everything healthy and on track. Like Daryl just mentioned, we will hear from Omar Baez, the NASA Launch Manager. He'll be polling the NASA team so that he can in turn report out on the ULA Launch Conductor poll that will happen a few minutes later. So that should happen right here at L-13 minutes. Let's listen in for that now.
This is the NLM on the NLMnet, just providing an update. The range did notify us that one side of the JDMTA command site.
Hey, so let's go ahead and we're going to step away from that for now, and we're going to, obviously there's something developing there. We were expecting to get that poll, and so we want to be respectful of what's happening there. The technical data, we're not sure that that's going to be approved for release, so obviously we'll be standing by to pay attention to that and give you updates as we understand more, but do want to kind of get back on track with talking about the, we are hearing that we think Omar is going to pick up with this poll. Coming up now.
NASA CE, go.
SMA?
SMA, go.
SMD?
SMD, go.
NASA Mission Manager?
NASA Mission Manager, go.
LSP?
LSP is go.
Copy that. The NASA team's ready to release the hold at T-minus 4 minutes.
Yeah, so Joshua, what we heard there from NASA Launch Manager Omar Baez is he was basically just briefing his NASA team and spacecraft customer of an issue that the team, that the range had notified them of with one of their downrange assets. It looks like it was partially mission capable today. The team accepted that, and they are ready to move forward, as you heard in the poll, that all systems are go for the NASA side. And we'll be picking that up as Launch Conductor Scott Barney does his poll here in a little bit.
Yeah, always a lot of things in play. We will continue to track that. Again, a great sign that the team was able to work through that and approve to move forward. So we'll be back in a few minutes bringing you the final steps of the countdown and a report up as we transition Lucy into internal power. But for now, Daryl, back to you.
All right, thank you, Joshua and Mick. Lucy is going to visit as many asteroids in the faraway belt of Jupiter as we've ever discovered for near-Earth asteroids. And to get there, Lucy will need the right rocket and the right trajectory to carry out this historic mission. We headed out to ULA's Vertical Integration Facility, where inside we were awestruck after walking onto a platform 18 stories above the ground, because just a few feet away was the Lucy spacecraft, inside its protective fairing and on top of an Atlas V rocket. ULA was making final preparations to roll this entire launch vehicle out of the vertical hangar we were in and onto the launch pad. Jermaine Oliver, good to see you, my man.
Good to see you too.
Hey, thanks for coming out here and telling us about this flight trajectory and all the fun facts about Lucy going up into space.
It's my pleasure.
So, Jermaine, you are a flight design analyst with Launch Services Program. You know this flight pretty well. Tell me first about why we're launching at this specific time of year.
We're trying to rendezvous with two different sets of asteroids that are on the Jupiter line, Jupiter orbit. So in order to do that, you have to launch at a particular time to line up where the asteroids are going to be at, because if you don't, you'll either get there too early or get there too late.
Can you believe how close we're standing here next to the spacecraft?
I've never been this close before. This is great.
Let me ask you about this fairing. What's its purpose?
The fairing purpose is to encapsulate the satellite throughout the time it's going through the atmosphere until it gets into space.
So let's talk a little bit about the orbit. So this spacecraft is going out 530 million miles away from the sun. That's far, and it takes a careful orbit to get there.
Yes, what happens is you have to use Earth gravity assist to slingshot yourself to each of the different asteroid Trojans.
So Lucy weighs about the same weight as a mid-sized vehicle, 3,400 pounds or so.
Yeah.
So it's pretty heavy. What kind of thrust does this rocket need to get it up off the ground and into space?
Max thrust on this particular rocket is about 930,000 pounds of thrust, and to get Lucy on a trajectory that's going about maybe 27,000, 28,000 miles per hour.
Tell me about this rocket configuration, the Atlas 401.
It's just a 4-meter fairing that works great for this mission because given the spacecraft's weight, about 1,500 kilograms, and where it's going, the energy that it's going to, this particular rocket fits perfectly with it.
I'm really excited about the journey as it begins right here, right now, with this entire rocket and spacecraft rolling out to the pad. That's pretty cool.
Yes, it is. I've never seen it before, actually. I'm excited to see how this goes today.
You want to jump on and ride with the MLP?
Oh, no, thank you. I'm fine.
You gonna pass on that?
I'm okay.
Okay. Oh, look there. It's moving. Check it out. Well, Lucy's journey has begun. Isn't it amazing?
Yes, it is. Lucy's on her way.
Jermaine Oliver with Launch Services Program. Thank you so much for being here.
Oh, it was a pleasure being here. Thank you for having me.
And as that rolled out, we had to take some pictures and even a selfie because, you know what? I feel like we're the last people to be that close to that spacecraft going so far away.
Yeah, yeah. I mean, and few people get to be at the base of the pad. Even fewer get to be inside the VIF, especially at that moment of rollout. So that was a really cool opportunity
awesome.
that you had. All right, we are inside of L-8 minutes and coming up on the launch conductor poll shortly. So we want to hand it over to Joshua and Mick to take us the rest of the way through the countdown. Joshua?
Hey, thanks, Marie. I would love to say that rocketry is a team sport, and that's what we're going to get to kind of hear with this launch conductor poll in just a minute. 4 major teams that play this morning. NASA Launch Services Program responsible for the launch. United Launch Alliance providing the vehicle, the ride to space. We have the Southwest Research Institute, the NASA's Goddard Space Flight Center, and Lockheed Martin, part of the Spacecraft team, and then the Space Force.
Yeah, Joshua, we're very happy to have Space Force here as they protect the range and look at the weather. They're also responsible for vehicle and personnel safety today.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems, propulsion.
Behind.
Go. Pneumatics. Go. LO2. Go. LH2. Go. HASGAS. Go. Electrical systems, airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operations support. Go. COM. Go. Umbilicals. Go. ECS. Go. Red line monitor. Go. Quality. Go. Ops safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 0934 Zulu.
Verified.
So Joshua, a very successful poll there by launch conductor Scott Barney. As you also heard, we verified that T0 is set for 0934 Zulu time. That's 534 local. Very happy to hear everybody green and go, and in particular, our friends at the range there, our Space Force friends, gave a clear for the range today. That's awesome. They're doing their job not only with weather but the safety. We also heard a little earlier in the count this morning that the range reported there are no COLAs this morning, which are collision avoidance assessments. So we are good for our first initial part of the launch window this morning, 5:34.
All steps are complete prior to terminal count.
Yeah, big thanks to the Space Launch Delta 45 folks for all their support. So looking ahead to terminal count, we just heard the call that the spacecraft is configured for flight. That includes being transitioned to internal power. And then, like I mentioned before, the next few steps are all about getting the launch vehicle and the spacecraft able to live on their own. So those are the things coming up here. We do have this release of the built-in hold. The eagle-eyed viewers that can see behind us might have noticed that there's a clock sitting at T-minus 4 minutes and holding. It's been that way for our entire show so far. That will then sync up with our L clock you see on screen at this moment, and those will count towards 0 together. Again, everything looking great for liftoff on time here at 5:34.
Yeah, Joshua, as we come out of this hold, what's very impressive this morning is this Atlas 401. We heard Jermaine talk about it. It's a 401 configuration, a 4-meter fairing, 0 solids on it, and 1 single Centaur engine on the second stage. This is a great configuration for the Lucy mission. It is the most common flown configuration by United Launch Alliance, and this will be the 89th Atlas V launching, so we're very proud of that.
2, 1, mark.
And there we go. The clocks are released, so we are ticking down here towards liftoff.
Ground pyros enabled.
Yeah, we'll hear the team securing a lot of their things, getting their final configurations in place, and making sure the rocket is ready for a T0 liftoff this morning. So the team will be working very quickly.
Yeah, and opposed to the missions that we might be used to with where we're hitting a low Earth orbit trajectory, this one is going into deep space, and so we'll be exceeding escape velocity of Earth this morning. So that's up and over 25,000 miles per hour. We know that over the course of Lucy's mission, she will get up to about 400,000 miles per hour. So very, very fast with all those Earth gravity assists. And for those that are in the physical area, you'll also notice that this rocket will take a little bit more of a southern track than we're typically used to seeing. We usually see rockets take off more towards the northeast. This one will move a little bit more towards the southeast than is typical.
Yeah, and with that southerly trajectory, people ought to be able to see some great things with the weather the way it is today.
3 minutes.
So,
Atlas tanks to flight pressure.
Securing LO2 topping.
250.
FTS internal.
So there we heard the teams securing the topping and bringing the Atlas tanks to flight pressure. That's a huge milestone as we get ready for T0 this morning. The teams have finished putting LOX and hydrogen on board and making sure that all that 740,000 pounds of fuel is there for liftoff of Lucy. We also heard that the team brought in the flight termination system arm. That is part of the range safety that is needed for the vehicle as we lift off this morning.
Yeah, previewing what's to come ahead, so stay with us after liftoff. We'll be tracking with a couple burns of the Centaur, spacecraft separation, those beautiful solar arrays deploying, and then signal acquisition of signal will kind of be the end of our show for you today, beginning a 12-year, 4 billion mile journey for Lucy.
Absolutely.
159.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
FTS armed.
90 seconds to go.
$120.
OCU's armed.
FCS count started.
$110.
Vent valves locked.
$1 minute.
Rock, report range status. Range screen.
All right, so stay with us again after liftoff. We'll also have the voice chiming in from Rob Kesselman from ULA. He'll be providing the launch vehicle Ascent data.
$40.
Stable at step 3.
So that's a great sign right there, stable at step 3. Everything is at flight pressures. We're now the only thing left, Joshua, is that final status check with the whole team.
25 seconds.
Status check.
Go Atlas.
Go Centaur.
Go Lucy.
Seven, 6, 5, 4, 3, 2, 1, 0. Liftoff. Atlas V takes flight, sending Lucy to uncover the fossils of our solar system.
Tower clear. RD-180 propellant utilization has gone to closed loop control. The vehicle has begun the pitch yaw roll maneuver.
30 seconds into flight. Vehicle is 0.6 miles in altitude, traveling at 939 miles per hour. RD 180 performance continues to look good at this time. Engine pump speeds and injector pressures are in family for this thrust level. Atlas vehicle attitude remains stable at this time. Attitude rates are near zero in all axes. Now at T plus 70 seconds into flight, vehicle is 4 miles in altitude, 0.2 miles downrange distance, traveling at 1,200 miles per hour. Mach 1, Atlas is now supersonic. Vehicle is now passing through max Q, maximum dynamic pressure. The vehicle is now throttling down slightly. RD 180 engine parameters continue to look nominal after the prior adjustment to the thrust level. Approximately 2 minutes remain in the Atlas booster phase of flight. The Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of 2,600 pounds per second. Vehicle is now executing closed-loop steering. Centaur reaction control system is now pressurizing the flight levels.
So beautiful launch sequence there. We do have another minute and a half or so to go with the booster in operation, getting Lucy.
We're now just under 3 minutes into flight. Atlas is 33 miles in altitude, 59 miles downrange distance, traveling at 5,600 miles per hour.
So Lucy being lifted up out of the atmosphere by the booster, getting on its way into a park orbit before we get towards...
All first stage vehicle systems are operating as expected at this time.
Future portions of the launch activity, we have the Centaur multiple burns ahead and spacecraft separation.
Yeah, the big milestone we should see, Josh, coming up is booster engine cutoff, which would be the first stage cutoff and then stage
separation. The main
separation.
engine is now throttling to maintain a constant 5G acceleration limit.
We're going to see a few things happen pretty rapidly. The booster will cut off just after 4 minutes, and then within the next 15 seconds after that, we should see the Atlas separate from the Centaur, and then the Centaur engine ignite for its first burn.
Centaur has begun the boost phase chill-down sequence, and the RD 180 is now throttling to maintain a constant 4.6 G acceleration limit. Boost phase chill-down sequence has completed, and we have BECO, booster engine cutoff, and a successful stage separation event.
So what you're seeing on screen is an animation that's being driven by actual telemetry
data.
data.
On the RL-10.
So we are watching these things in an animation happen here, but they're happening in real time as well.
And mess 1, we have ignition for the first burn.
All right, so there we go. We should see the fairing jettison here.
We have indication of good payload fairing jettison.
And there we go. All right, Mick, so that wraps up the first round of major milestones here. Still very much in the middle of dynamic flight.
The TU system on the RL-10 is now in an open-loop burn-off mode to burn off excess fuel in the early portion of this burn.
So walk us quickly through, Mick, what are we looking for in this burn and the next one?
So this burn is going to end with MECO getting Centaur and Lucy into its park orbit around Earth. And then we will then get into MESS 2, which will get us into that transfer orbit, getting Lucy on its way.
Awesome. So that's going to do it for now. Finishing up the initial launch activities, everything sounding like it's going perfectly. Daryl, back to you.
Thank you, Joshua and Mick. A beautiful launch out here from our vantage point, incredible. All right. Lucy was built at the Lockheed Martin facility in Colorado before arriving at the Cape Canaveral Space Force Station for launch. Engineers at Lockheed's Waterton facility use lessons learned from prior spacecraft like New Horizons and OSIRIS-REx to build Lucy.
And in July, Lucy was packed up and flown on board a United States Air Force C-17 cargo plane from Colorado to the Launch and Landing Facility runway at the Kennedy Space Center. From there, Lucy was transported to an Astrotech Space Operations Processing Facility in nearby Titusville for final preparations before liftoff.
Yeah, just a few miles from here before it was brought to the pad. For more about how Lucy was built, let's send it over to NASA's Megan Cruz.
Hey, Daryl. Yeah, right now I'm joined by Ari Vogel. He's the Deep Space Exploration Director at Lockheed Martin Space. How are you?
I'm doing wonderful. Thanks so much for having me.
Wasn't that just a beautiful launch? What did you think about that?
Incredible. You know, seeing it go over the clouds and brighten up the whole sky was just fantastic.
Yeah, to see it rise over the clouds, because, you know, we lost it a little bit because of some cloud coverage, but then it just rose out of it. It was so beautiful. And, you know, I really wanted to talk to you because your team at Lockheed Martin Space knew that you were going into a project that would require you to develop a spacecraft that would travel farther than any other solar-powered spacecraft ever. I mean, was that intimidating?
You know, it was a really exciting challenge to solve, right? And obviously, the most prominent feature of Lucy is their big solar arrays. Each one is about the length of a bus. And, you know, what we did is we basically just broke the problem down into smaller pieces and then applied systems thinking to make sure that the design trades we were doing didn't impact, or that we fully understood the impacts for over the 12-year mission. So, you know, being the farthest solar-powered spacecraft is certainly something that was difficult to prepare for, as is going to a record 8 asteroids in one mission. But that's why we have such a comprehensive Test Like You Fly program at Lockheed Martin, and we took it through the ringer at our facility in Denver.
Yeah, and you did it all within 14 months. That's during a pandemic. That's incredible. Can you talk to me about the challenges of that?
Yeah, you know, it's really awe-inspiring. I mean, to be able to build a one-of-a-kind spacecraft during normal circumstances is incredible. And the team just really pulled together, didn't miss a beat, connected and collaborated, you know, made sure that we didn't have any mistakes. And it really accelerated some of our digital transformation initiatives too, having to work during the pandemic. And not a single shift was missed during integration and test due to COVID. So team just did an awesome job, leadership with the preparation and the over-communication and the transparency. And then all the team, you know, just didn't let their commitment to Lucy waver. And I think the thing that I'm most proud about actually is that through it all, we still continued all of our STEM events, all our mentoring, our coaching, Lockheed Martin, NASA, Southwest Research Institute, hundreds of thousands of hours into that. So it was really, really a great job.
And really quick, you also built the antenna that's on there that's going to help us communicate with Lucy. Can you tell me a little bit about that?
Yeah, we did. 6.5 foot wide antenna that we built. Main job is to do the communication between the spacecraft. And, you know, it's also going to send back some of the first images of the Trojans. So the whole team is super excited for that.
Yeah, absolutely. Thank you so much, Ari. I really appreciate you being here today and for bringing Lucy to life. So thank you.
Thanks for having me.
All right, Daryl, back to you.
All right, thank you, Megan. And in case you're just joining us, we here at NASA are at the beginning of Lucy's 530-mile journey to the Trojan asteroids beyond the sun, going to the same orbit, Marie, as Jupiter.
That's right. It was a beautiful launch here. We could see it light up the water behind us, and we actually had a gator in the water just behind us. Oh, joining us for liftoff. Yeah. Lucy is named after a skeleton fossil more than 3 million years old. Lucy was an early human ancestor, and the Trojan asteroids are fossils, too, of how planets were formed.
Beyond the asteroid belt are fossils of planet formation, known as the Trojan asteroids. These primitive bodies share Jupiter's orbit in 2 vast swarms, leading and trailing the planet. Now, NASA is preparing to visit 7 asteroids. Embarking on a 12-year odyssey that will span Jupiter's orbit. One mission will explore these objects for the first time. Lucy, the first mission to the Trojan asteroids.
And another special guest that we had watching the launch from the Atlas Spaceflight Operations Center was none other than NASA's Associate Administrator, Bob Cabana. He is standing by with Blair Allen of NASA Edge. Actually, they're telling me that we lost audio with that group, so we will come back to that if we can, but while they try to work out their audio issues. But Daryl, we had a really unmatched view of launch here. It was just spectacular.
Yeah, it was incredible because we're sitting, you can't really tell, but this behind us is the Kennedy Basin,
right.
The turn basin where they've brought in, the space shuttle main tank, as well as just recently the core stage for the Artemis rocket, which is in the VAB right now getting stacked. You're looking at the flight of Centaur and Lucy. We are L plus 11 minutes and 26 seconds as we cruise along, and we want to talk a little bit now about the message that Lucy is going to be sending.
That's right. Lucy is carrying something on board. Aside from her scientific instruments, she's got something a little more philosophical. There is actually a plaque affixed to the side of the Lucy spacecraft, and it contains quotes and messages from artists, poets, and thought leaders. And the plaque is meant to serve as a time capsule of sorts for our own descendants. You see, after Lucy's 12-year mission is complete, the spacecraft will remain on a stable orbit, traveling back and forth between the Earth and the Trojan asteroids for perhaps hundreds of thousands of years. And one day, in the distant future, our descendants may be able to retrieve Lucy. There it is, the plaque you can see on the side of the spacecraft. Wow. This was before Lucy was packed inside the payload fairing. But this is meant to be a relic for our descendants of the early days of humanity's exploration of the solar system. And when they do, they will see some great messages. We'll see those. We'll talk more about those in just a couple of minutes. We actually we do have it. Yeah. So this is a representation. It's hidden a little bit behind your computer, Daryl.
Oh, yeah, let me get that down. Thank you.
But this is the actual plaque on the spacecraft is about a tenth of the size of this, so this is blown up.
Yeah.
But it's got a diagram on it. This shows the positions of the planets as they are today on the day of the Lucy launch.
That's right, and there are some great quotes. You mentioned some of the great philosophers and thought leaders over time. Down at the bottom left, you can see that one there is from Albert Einstein. The important thing is to never stop questioning. And then in the middle, we've got the Beatles. In fact, every single Beatle is here, including John Lennon. And he says, we'll all shine on like the moon and the stars and the sun. And then up here at the top, actually right here on the far right, we've got Amanda Gorman, who just came to recent fame at the presidential inauguration. She actually wrote this poem specifically for Lucy, and there's a great quote in here. She says, hope implores us, may the ancient study and the uncompromising core of us to keep rising for an earth more than worth fighting for. Great words from a young poet.
Yeah, she's an amazing poet. Just blows me away. We are going to now get a look at some more of the messages that we intend to leave behind for our descendants. Take a look.
And this is what I want to say to people, to beings, to consciousness who are so far away, I can't even imagine them.
To represent our culture accurately, we should include hopelessness, risk-taking, the role of fortune, good or bad.
To understand each desire has an edge, to know that we are responsible for the lives we change. No faith comes without cost. No one believes without dying. There are no curses, only mirrors held up to the souls of gods and mortals.
Remember, you are all people, and all people are you. Remember, you are this universe is you.
I would just like to say that this wonderful emissary to the Trojan asteroids is itself a message. Lucy speaks for all that is best about human ingenuity, curiosity, and endeavor.
Do you still have birds that wake you up in the morning with their singing, and lovers who gaze at the stars, trying to read in them the fate of their love? If you do, we'll recognize one another.
And receive those words inscribed on a plaque from all of us, for all of us, filled with those aspirations and that inspiration and that imagination that we need so much right now.
A little noisy, but I'm so excited. Lucy is going back in the sky with diamonds. Johnny will love that. Anyway, if you meet anyone up there, Lucy, give them peace and love from me.
All right, we've got that audio issue taken care of, so we're going to go over now to NASA Edge's Blair Allen, standing by with Bob Cabana. Blair?
Thanks so much, Marie. Yeah, sorry about the technical difficulties. You know, the launch was so impressive, even our gear was affected. But Bob, it's really impressive to see this launch this morning. Tell us, how is it from your perspective?
Well, first off, from my perspective, I got my very own NASA Edge microphone. I'm just elated. Now, Blair, you know, anytime you see a rocket ship leave planet Earth, it is an experience. It's a feast for the senses, sight, sound, and feel. It's emotional. And having Lucy on board, I mean, this is the coolest darn mission, going to the Trojan asteroids. Looking back at the beginning of our universe 5 billion years ago, absolutely amazing.
And that's kind of what's impressive. I mean, we're talking about this important science mission, but here at Kennedy, we've had 24 launches so far. What's going on?
Well, I tell you, first off, I could not be more proud of our NASA team, our contractor civil service team that has persevered through this pandemic, not missing a beat, you know, making all our missions. I mean, we've launched humans to the International Space Station for the first time since the end of the shuttle program during it. We've launched Perseverance to Mars. You know, we're getting ready to launch James Webb here in December. That's going to be amazing. And getting Lucy off on time. You know, if we didn't get off in this launch window, we're talking another year before we launch.
Yeah, and that is impressive to see how things came together so perfectly. But tell us a little bit about what's coming down the pike. We've seen a lot of things happen here at Kennedy and lots of things to look forward to.
Well, absolutely. You know, I mean, first off, from a science mission point of view, of course, next month we're going out to the West Coast for DART. Then we're coming back here in December for IXBI. In December, down in French Guiana, we're launching James Webb. What an amazing telescope that's going to be. A 21-foot mirror, you know, and then a solar shield, a sun shield the size of a tennis court. You know, they talk about the 9 minutes of terror landing on Mars. Right. We're talking 4 weeks of nail biting as that thing unfolds. But to look back 13.5 billion years, almost to the beginning of our universe, you know, 350 million years from the beginning, it's going to be amazing. And then over in the vehicle assembly building over there in High Bay 3, stacked up, is that awesome Space Launch System, that Boeing core stage with the Northrop Grumman solids and those 4 Aerojet Rocketdyne RS-25s. The Orion spacecraft rolls over here on the 19th, stacked down on top. It's going out to the pad for a wet dress rehearsal, and then we're going to launch it to the moon. We're going to do that first test flight without crew in preparation for going back to the moon in a sustainable way so that we can go on to Mars. Just so much going on.
I love it. Thank you so much for being on the show. From Center Director now to NASA Administrator, back to you, Marie. Great things here at NASA.
All right, thank you, Blair. One of the asteroids Lucy will visit, Euripides, has already given researchers a recent surprise revealed by the Hubble Space Telescope. Take a look.
On January 9th, 2020, NASA's Lucy mission team revealed that the spacecraft would be visiting not 7 asteroids as planned, but 8. As it turns out, Euripides, one of the Trojan asteroids along Lucy's path, has a small satellite or moonlet orbiting it. Finding these tiny new worlds before Lucy is launched in 2021 means that the team can investigate their orbits and plan for more detailed follow-up observations during flybys. Dr. Keith Knoll and other Lucy science team members have been using the Hubble Space Telescope to search for satellites and rings around Lucy's targets. This can be challenging, since the raw images are often filled with bumps, blobs, and diffraction spikes. The Lucy team didn't see any evidence of a new satellite until November 2019. After experimenting with the brightness and contrast on the Hubble images, Dr. Knoll saw a peculiar faint spot near the much brighter Euripides. Dr. Mike Brown, another team member, noticed the spot showed up in a slightly different position on another set of Hubble images taken 2 days later. This change suggested that the spot was an orbiting satellite. The team went back to Hubble and got 3 more chances to make observations of the possible new satellite. On the first 2 tries, the little moonlet was nowhere to be found. But on the 3rd observation, on January 3rd, 2020, they found the possible new satellite again. It was clearly visible next to Euripides, which was over 6,000 times brighter. This huge difference in brightness suggests that the satellite is less than 1 kilometer in diameter, very small compared to Euripides at 64 kilometers. With a few more Hubble observations, the team pinned down the new satellite's orbit, and they proposed a name. The International Astronomical Union approved, and from now on the little satellite will be known as Quetta, after Enriqueta Basilio, the first woman to light the Olympic cauldron. Evidence indicates that the Trojan asteroid Euripides is the largest fragment from a massive asteroid collision that happened billions of years ago. It is possible that the new satellite Quetta is a remnant of that catastrophic event. Whether with Hubble or with the Lucy spacecraft's flyby, each observation enriches our understanding about the Trojan asteroid's formation and Euripides' relationship with its newly discovered companion. The discovery of this new moonlet around the Trojan asteroid Euripides is just a preview of the incredible scientific knowledge that will be captured by the Lucy mission as it explores this area of our solar system.
All right, our next guest is one of the great minds behind the mighty Atlas V, which just had another spectacular launch here. He's standing by with Franklin Fitzgerald from NASA Edge over at the ASOC. Franklin?
Yeah, thanks, Marie. I'm here with Scott Messer, ULA Program Manager. Scott, how did the launch go from ULA's perspective?
Well, it was near perfect so far. We never claim success until we separate and get the spacecraft where it wants to be, but so far the first stage was great. The countdown was very quiet, and it's a beautiful launch so far.
Great to hear. This is a mission unlike any other before it. Can you tell us exactly how unique the trajectory was for the Atlas V on this mission?
Yeah, so certainly the trajectory for the spacecraft is very unique. Probably never been done before. But from an Atlas standpoint, we've launched many planetary missions over the years, and we just kind of did our standard thing in order to get the spacecraft ready to go.
You know, getting ready for this mission through COVID was a challenge for, I know, many people. Were there any challenges that you had to overcome? Is there any kind of anecdote that you can tell about this mission?
Yeah, so the team, it's been a very aggressive week, a couple of weeks with us. You know, we launched Landsat 9 just a few weeks ago, turned around the end of the week, so we launched on Monday, and we turned around and had the wet dress rehearsal here for Lucy on Friday, and then turned around and did our Vulcan PTT test here. So it's been really a very exciting week for the team here, and the team has worked really hard through all the COVID stuff, through all of the activities, in order to maintain the launch date. And here we are right at the beginning of the window, and a beautiful launch so far.
Absolutely. Well, Scott, we wish you the best of luck over the next 12 years, and thanks for joining us here on the show today. Marie, Daryl, back to you to learn more about science.
All right, Scott and Franklin, thank you very much. As you look at the bottom of your screen, I want to remind you we have a progress bar, which is tracking where we're going. You can see that we had the main engine cut off. We're awaiting that second burn of the Centaur, and of course, we'll have all of that for you. But we have about an hour to go before signal acquisition from Lucy. Only then will the team be able to breathe a sigh of relief. So let's hear from some of the scientists about their passion for Lucy in their own words.
Hi, my name is Danya Douglas Bradshaw, and I'm the project manager for the Lucy project, which will be the first mission to the Trojan asteroids. Building a spacecraft is quite exciting. I worked many decades as a mechanical engineer, really focused on thermal and heat transfer. And so when you work in that capacity, you are supporting the development of spacecraft as well as instruments.
Hi, my name is Dr. Carly Howitt, and I'm the instrument scientist of the MVIC camera on Lucy. I love working on Lucy for so many reasons, but one of them is being able to explore the universe from the comfort of my own office. So I don't have to don diving gear or, go into these dangerous or hard situations. I get to enjoy the data as it comes back from the comfort of my office and explore the universe that way.
My name is Corey Preikel, and I am the mechanical operations lead for the interplanetary spacecraft Lucy. My job is to plan and lead major mechanical operations such as spacecraft transportations, spacecraft crane lifts, or testing of major spacecraft components and ensure they go off without a hitch.
My name is Mike Sakarik. I'm the Deputy Project System Engineer for Lucy. The thing I like the most about Project System Engineering is that you get to touch all aspects of the mission, from the spacecraft, payload, launch vehicle, ground systems, flight dynamics. Project System Engineers have oversight of all of those different aspects of the mission.
I'm Tiffany Kapler. I am a public outreach specialist with the Lucy mission. And one of the things that I love about my job is that it gives me an opportunity to use my creativity and share my enthusiasm for science with others while I get them excited about space exploration.
Hi, I'm Rick Berry, and I am the Configuration Management Lead for the Lucy mission at Goddard Space Flight Center. We're building spacecraft, we're building payloads and instruments at Goddard. We coordinate with our team members to ensure that the configuration management is correct by managing the changes and the requirements.
Hello, my name is Elizabeth McCall, and I'm the Project Support Specialist for the Lucy project. One of the more memorable experiences I've had was just in July of this year. I was able to fly with the spacecraft from Colorado to Florida on a C-17.
My name is Vince Elliott, and I'm the Lucy Deputy Project Manager over Resources. I lead a team of 12, and they are exceptional at what they do. It also means I get to work with some of the brightest engineers and scientists the world has ever known, doing something that I love.
Hi, my name is James Traley, and I'm a producer and animator at NASA Goddard Space Flight Center. And I created the video series you're currently watching right now. I'm so excited to see Lucy launch, and I can't wait to share the complex and exciting discoveries that we make out there at the Trojans to you, the public, through film and animation. Go NASA, go Lucy.
This Lucy mission is dedicated to a number of team members at NASA and United Launch Alliance, some of them no longer with us today. There are 3 dedications placed on the side of the Atlas V rocket. The first says Lucy Strong, recognizing the team's hard work throughout the COVID-19 pandemic. There it is. We got a shot of it before liftoff. And the second is a memorial to ULA team members Mark Kazabowski and William Billy Joyner. Mark was an accomplished engineer and respected mentor. During his 30-year career, he focused on launch vehicle structures and integration. He led the structural design of the Atlas II, 2AS, and 3 development programs. Mark was also a family man, reminding his team always to take